Okay, so just a little summary on the data structures we we saw for the dynamic list ADT. If we tabulate the operations we do on these structures, uh, across the board, the linked list data structure has a uh, linear time for all operations, while the dynamic array has a advantage in access time. However, we do need to show when these worst cases, since the big O notation takes into account the worst case, we need to show when these worst cases actually occur. So for the simply linked list, inserting at the start or deleting at the start actually takes constant time since we don't have to traverse the list anymore. And then inserting in a dynamic array would always have a sort of linear worst case running time since we have to reallocate at the worst case. So actually, let me just correct this. The delete at the end for a dynamic array would actually just run in constant time since we don't need to shift elements anymore. So note that change over here. Sort of I apologize for that. And then so actually for the insertion at the end, you can argue that it's at constant time, but because we need to sometimes reallocate, and that is the actual worst case, we say that it is O of n. So by comparison, if we ever just needed to insert and delete at the front of the list, single linked lists would actually be a somewhat more attractive option for us. However, if we just set up the array one time and we just need to look up the values in a table, for example, a dynamic array would be the most fitting thing. And let me just reiterate what I stated earlier about linked lists. Some some computers may not be able to handle dynamic arrays. Some might not be able to handle linked lists. And some might not even be able to handle both. So there actually more are other data structures that you can implement for the dynamic list ADT, but these are the most common ones. And most of the time, they can be implemented in the level of programming that we are handling. So that's it for this half, basically, of the week.